First, a short note about solving an equation using absolute value. Just like solving most equations, you're going to want to isolate the absolute value. Do not worry about isolating x. Isolate the absolute value. So first of all, we're going to get rid of this negative 3 by adding it to the other side. So when we do that, we are left with x plus 7 is equal to 14. Now step 2 suggests to check to see if the other side of the equal sign has a positive value. And when we look, 14 is positive, so we can continue. And we'll see why it doesn't work when it's negative. So now our job is to solve for both the positive and the negative values of 14. We're going to solve x plus 7 is equal to 14, but we're also going to solve x plus 7 is equal to negative 14. Because as you recall, if you're finding the absolute value of something and it's equaling 14, the positive 14 version and the negative 14 version will still both be solutions. So let's solve these equations. We're going to subtract 7 from both sides so that I get x is equal to 7. But I'm also going to subtract 7 from this crazy problem and get that x is equal to negative 21. Both are solutions. If you like to solve one equation instead of two, what you can actually do, just so you know, is once it's isolated, once you've gotten to this stage and you know that it's positive, you can do this. X plus 7 is equal to 14, and you can also say it's equal to negative 14 over here. And you can just solve the one problem. The only thing is, at the end, you technically do not want to leave it like this, because negative 21 does not equal 7. Yes, x is equal to both, but you don't want to write it like this. You would want to write it as x equals 7 and negative 21. Now for an alternative problem. Again, we are going to isolate our absolute value by getting rid of this positive 9. So I'm going to subtract 9 from both sides. When I do that, I get the absolute value of 5x plus 7 is equal to negative 3. Step 2 says, check to see if the other side of the equal sign has a positive value. And it doesn't. We are finished. Stop here. Because there is no absolute value in the world that will come out negative. Absolute value always comes out positive. So, since it doesn't work, you're finished. This has no solution. So now just a quick going over of and versus or. We're going to move on to what happens when we actually have an inequality, not an equation. Now, what I like to do to tell is to just do this. You're going to copy exactly what's written there, right? Don't flip it, don't do anything. And you're going to also write the opposite of the number that is here. And you're going to ask yourself, is negative 4 less than 4? And it is. So this is an and statement because it actually works. And that's because it follows the transitive property. If you read it across all of this, it actually makes sense. So anytime your inequality is eating the number, away from the absolute value, it is an and statement. Whenever your inequality is actually eating the absolute value, this is going to be an or statement. And again, using the transitive property, we're going to see that it's an or. If we continue in the same direction we put this, is negative 4 greater than 4? And the answer is no. It is not greater. So that means it's an or statement. It can't be an and statement if it's not true. So you're going to practice telling me things are and or. So all I want you to do is for tomorrow, I want you to bring in the answer to these two. A is going to be first. You're going to write x plus 5 is less than or equal, is greater than or equal to 10. You're going to also bring in p, 2 times x minus 5 is less than 12. And I want you to just decide, are those and or, and bring those in tomorrow. Check out the next video for how to actually solve the problem.